So let's take a look at this more challenging problem. We have to find a place for point Q that separates this segment into a ratio of 5 to 2. That means 5 parts versus 2 parts. We have to figure out where's Q going to go along here to separate the segment accordingly. So we can tell already SQ represents 5 parts, QT represents 2 parts. So Q is definitely going to go closer to where T is. 5 parts versus 2 parts means that we are going to have 7 parts total. So let's figure out, how do we break up this segment into 7 equal parts? You might initially think to use the distance formula, but because we can't really count these spaces very well, the distance formula isn't going to help us. It's going to be way too complicated. So let's actually think about creating a right triangle here. So that means I'm going to start at S, I'm going to count over, and then up to T. That means I should be getting 7 spaces over and 14 spaces up. Both those numbers, very conveniently, are divisible by 7. So if I want to take, instead of moving 7 spaces over, let me divide that up by 7. 7 divided by 7 means I'm going to just be moving over 1 space per part. And if I divide 14 by 7, that means I'm going to be moving up 2 per part. So let's count that each time. We can move over 1 and up 2 to get 1 point, then another point, then a third point, another point, one more point, and one final point. That separates 1, 2, 3, 4, 5, 6, 7 segments. 7 equal segments, because we move the same distance over 1, up 2 for every individual segment. So that means I can count 5 segments starting at S, 1, 2, 3, 4, 5, and figure out that this point here separates 5 parts versus 2 parts. So point Q has to be at 3, 4.